Alright, so we're going to continue from this slide. Right, so now we saw with an if-else statement in this previous slide, you can basically use conditional statements to choose between two courses of action. If the condition's true, we do this first thing. If the condition's not true, we do the second. This next structure, an if-else, is basically an expanded conditional that gives us a lot more options. It basically lets us take a bunch of conditions and choose one course of action. So the way it works is you always have one if. It's always if the first condition is true, we do these statements. And then we can have 0, 1, 2, 3, 4, or as many as we want, other conditions. Basically what happens is we say, if the first condition is true, as we said, we'll do this. If it's not true, then we'll check the second condition. If the second condition is true, then we'll execute these statements. If the second condition is not true, well, then we'll try the third condition. And if the third condition is true, we'll execute these statements. And so on and so on and so on. Right? And sometimes you want to have, a whole bunch of else-if conditions, right? And each of these, as implied, starts with else-if. Right? You want to have a whole bunch of those, but then you want to have a default, a fallback option. Say, if none of these litany of conditions I'm giving you are true, or then we'll go with the else. So the else is basically a fallback. You can think of it as a condition that's always true. Okay, so we'll basically in MATLAB go through, say, is condition 1 true? If so, do this first set. Is condition 2 true? If so, do the second set. Is condition 3 true? If so, do this. And if we go through all the conditions and none of them are true, we'll get to the else. And the else will execute. Okay, so the key idea here is we're only going to do one of the conditions. We can never have a case where we execute these statements and these statements. That'll never be the case. You kind of go down the list of conditions and say, let's find the first one that's true, we'll execute that. So let's look at an example. In this example, we're going to assume that we get a variable called age. Right? And this can be from an input, it can be from anything. Right? Whoops. We'll assume it's from an input statement. So someone types in an age, and then we're going to choose one of these options. We'll say if they're over 65, whoever we're referring to, say they're a senior citizen. If they're not over 65, right, we would go to this next condition and say, is this true now? So we know if we get to this next condition, they can't be over 65. If they were over 65, the first condition would have been true. So now we would get to the second condition and say, okay, well, they're not over 65. Are they over 25 at least? Or rather, at least 25. If so, it'll display you're a grown-up. Right? And, if now we're saying, okay, first condition is not true. They're not over 65, or not at least 65. Second condition is not true. They're not at least 25. Then we'll try the third condition. And let's say they happen to be 19. This third condition would be true, and it would display you are a college student. Right? And it would keep going down this list if it weren't. And let's say they happen to be 4 years old. All these conditions would not be true. If they were 4, so age would equal 4, then this last thing would be true. It would, and the reason it would be true is the else is, by default, pretty much always true. If we get down to the else, we do what it says. So we would, if they were 4 years old, display, you are a little kid. Right? So let's move on. Here's kind of an example, and this is a naive example. And naive is basically scientific or mathematical parlance for this doesn't work. In this case it does work. It just isn't a very good way of doing it. Here, what we're going to do is ask the user to enter an integer, and then if it's 4 digits or more, we'll display the number has 4 digits plus. If the number doesn't have 4 or more digits, but has 3 digits, we'll display that. If the number doesn't have 4 plus digits, it doesn't have 3 digits, but has at least 2 digits, we'll display that. And so on. So you'll notice there's one trick here. If we get here, they don't have 4 or more digits. They don't have 3 digits. They don't have 2 digits. And the number's not 0. Then, logically, the number must have 1 digit. So we don't even have to test. We can just say else. If we get all the way down here, we know it must have 1 digit. So we display that the number has 1 digit. Right? Of course, there's a better way to write this, and there usually is in computer programming. Right? So here what we see is us making use of functions we learned earlier. Right? First, we'll introduce a new function, ABS for absolute value. Right? An equivalent way of doing this would have been saying, x times the sign of x. Why? Well, if x is 0, sign 0. If x is positive, the sign of x is 1, so it doesn't change. If x were negative, the sign of x would be negative 1. So we'd have some negative number times negative 1. It would become positive. Right? So that x times sign of x and absolute value of x are the exact same thing. Right? Programming lots of different ways to do something. Right. So now let's look over here. So we'll make x positive, as I indicate in this comment. We'll say if x is 0, then display that the number is 0. Otherwise, we're going to do this weird-looking calculation. Right. Oops. And what this calculation rests on is this observation. So let's make a chart. Let's say, let's say we'll have a number 9. We'll have, let me move it over here. Of 9, 10, 11, 99, 100. Okay. So notice for each of these what the log base 10 of those numbers will be. So this is basically, a little chart. Log base 10 of 9 is going to be something. It'll be some decimal, maybe 0.9 something, somewhere around there. We know it has to be less than 1 because the log base 10 of 10 is 1. So log base 10 of 9 has to be a little bit less than that. Similarly, the log base 10 of 11 has to be a little bit more than 1, so 1.0 something, 1. Doesn't matter. Right? And let's see, log base 10, and I'm going to skip 99 for now. The log base 10 of 100 is 2. Right? 10 squared is 100. So therefore, the log base 10 of 99 is going to be like 1.9 something. Okay, so now what happens when we take the floor of the log base 10 of x? Okay, well, this rounds down to 0. 1 stays at 1. 1.0 something rounds down to 1. 1.9 something rounds down to 1. 2, it stays at 2. So if we add 1 to each of these, as we do above, we end up with 1, 2, 2, 2, 3. And notice that's how many digits there are in the number. Right? We're basically just going based on, log base 10. And saying, okay, well, when we get one more digit, it's basically we've gotten one more power of 10. And, in our base 10 number system, that's how it works. The log base 10 goes to the next, integer when we've reached a new power of 10. And thus, the powers of 10 are your first 2, 3, 4, 5, 6, 7, etc. digit numbers. Okay, so this is basically a tricky way, thinking about how log 10 is defined to count the number of digits. And of course, this doesn't implement any kind of error checking. A better program would have done something like that. Okay. And here's another example of conditional statements. One thing I want to point out here is this interesting example, 17 less than or equal to age, less than or equal to 25. Again, that doesn't work, as you might have noticed in your homework, from recitation problems last week. Right? And so let's look really fast at why that wouldn't work. Right? Let's say the age were 15. Right? So this should give false. And if we go look at MATLAB, say age equals 15, 17 less than or equal to age less than or equal to 25, gives true. That doesn't make sense.